Welcome to the final chapter of this course. In this chapter, we will introduce you to time series and we'll see how to analyze them. So, let's begin. Alright, so what is a time series? Well, it is a set of data points measured over regular intervals of time. For example, weather data over the last 5 years is a time series. By analyzing these time series, we can identify patterns in the data and can use these patterns to develop a forecasting model using machine learning. There are various Python libraries to study time series and develop machine learning models using those time series. Since this is an introductory course, we will be using the libraries that we have learned so far, namely Pandas, NumPy, and Matplotlib. In addition to these, we will also use the datetime module of Python, which supports date and time arithmetic. A time series, as stated earlier, is just a series of data measured over regular intervals of time. Thus, speaking in terms of pandas, any series is containing values measured at different time intervals is a time series. To use the time series functionality of pandas and perform arithmetic operations on date and time values, the data types of these date and time values in a pandas time series is either date time or timestamp. Any dataset with date and or time values can be treated as a time series in pandas provided that the data type of date and or time values is either date time or timestamp. In some cases, for example, for the time series of different stocks, we can download a time series directly within our Jupyter Notebook using libraries such as yfinance. yfinance is a Python library to download stocks data. It gets this data from Yahoo Finance as Pandas time series. Let's see how we can download and import yfinance in our Jupyter Notebook. In this tutorial, we will learn to download and import yfinance in Jupyter Notebook. To download yfinance, we use the command given in the slides inside our Jupyter Notebook: pip install yfinance. Let's run this cell. It will take some time. And here you go. The library has been installed in our system. Let's import it now. Import yfinance as yf. Note that you only need to install yfinance once, but you have to import it every time you want to use it. To download the stock's data using yfinance, we can use the .download brackets method. The .download brackets method takes the stock name as listed on Yahoo Finance, a start date and an end date as arguments, and returns the stock data over the specified time period. In the example on screen, we have downloaded the stock's data of Apple from the 1st of January 2022 to the 31st of January 2022. Note that the end date is not inclusive. Let's go to Jupyter Notebook to see how this works. Okay, so our library is imported. Let's download the stocks data of Apple for the month of January 2022. df equals yf.download brackets aapl, start equals 2022-01-01, end equals 2022-01-31, close brackets. Let's print the first 10 rows of our data set. df.head brackets 10. Let's execute this cell, and you can see that we have a data frame containing information about Apple stocks. In this case, each series of this data frame is a time series. Also note that the first row contains data for 31st of December 2021. This is the default behavior of yfinance in Jupyter Notebook. The data type of each value of the index column in the data frame from the previous slide is timestamp, indicating that this is a time series. Here is a small quiz for you. Stock's data over a period of regular intervals of time is indeed a time series. A time series can also be imported into Jupyter Notebook as a CSV file. If the data time values are strings, they can be converted to timestamp using to_datetime brackets function of Pandas. Consider the time series shown in this figure. The data time of date values is str. We will convert date values to timestamp using the to_datetime brackets function. Let's see how this works. Okay, so we have our libraries imported. Our time series is stored in the variable df. Let's change the data type of index column. df.index equals pd.to_datetime brackets df.index close brackets df. Let's run this cell. So apparently nothing has changed. Let's print the data type of the index column now. Type brackets df.index square brackets 0 close brackets. Execute it. And as you can see, the data type has now been changed and we can use the time series functionality on this dataset. In some cases, string date and/or time values of a time series might be in a format that Pandas cannot convert. For example, consider the date values in the given figure. The data type of index column values is string. Let's see what happens when we convert these values to timestamp. Once again, our dataset is stored in the variable df. Let's change the index value to timestamp. df.index equals pd.to_datetime brackets df.index df. Let's run this cell. And we have a parser error, which basically means that Pandas could not parse the string format of the index column. So, what is the solution to the problem that we faced? Well, the solution is to explicitly tell Pandas that the format of the index column values using the format parameter in the to_datetime brackets function. Let's see how this is done. Let's begin by printing the first 5 rows of our data frame. df.head brackets. Let's run this cell. Okay. So our date values begin with the year, then hyphen, then month, then hyphen, then day, then space, then time, then hyphen, and finally AM or PM. Let's pass this format to the format parameter. You can find the format codes on the link given in the slides. For this problem, our format string will include %y for year, then hyphen, then %m for month, then hyphen, then %d for day, then space, then %i for 12-hour clock time, then hyphen, and then %p for AM and/or PM. Let's write the code. df.index equals pd2_datetime brackets df.index, format equals %y dash %m dash %d %i dash %p close brackets df. Let's run this cell now, and the conversion was successful. In this section, we will learn about the time series functionality available in Python. We'll be using the dataset shown in the figure. Each column of this dataset is a time series. We can use the .day_name brackets function to see what was the day on a given date. This function only works on a date time or timestamp values and hence can be applied on the index column values of our data frame from the previous slide. Let's use this function to find out whether 1st of January 2022 was a business day or not, since there is no data available against this date in the time series. Let's create a date time value that would represent 1st of Jan 2022 as a timestamp. Jan1 equals pd.to underscore date time brackets 2022, 1, 1 close brackets. Let's see what was the day on this date. January 1 dot day underscore name brackets. Click run. So 1st of January 2022 was a Saturday, which means 2nd of January 2022 was a Sunday. So, since the 1st of January was a Saturday and the 2nd of January was a Sunday, we don't have any stock data for these two dates. In fact, the stock market is closed on weekends and is only open from 9:30 am to 4 pm Eastern Time, Monday through Friday. We can also find the maximum and the minimum timestamp values using the .max brackets and .min brackets functions. This could be useful when the data is not in order. We can also find the date time range simply by subtracting the maximum value of timestamp from its minimum value. We can also index a time series using the .loc method. In the given example, we get the row of the data frame where the date is 7th of January 2022. We can get a series. We can also slice multiple rows of time series using .loc method. Slide 34, working with time series 7. An interesting thing is to partially match a timestamp in a time series using .loc. Let's see how this works. Our dataset contains data for the months of January and February. Let's index the rows of the time series where the month is February. We can partially match the index values to the string 2022-02 in order to match February. df.loc square brackets 2022-02 close square brackets. Let's run this cell. We get only 3 rows from the month of February. Quiz time. Consider the given data frame called df. What value will the following command return? df.loc square brackets 2008-02-01 close square brackets. And here is the correct answer. In this section, we will learn to visualize a time series using matplotlib. We'll use the dataset shown in the figure. The ADJ close column represents the stock price at the end of each day. To be more accurate, adjusted close is the closing price after adjustments for all applicable splits and divided distributions. Let's plot this column in Jupyter Notebook. We will use the .plot brackets function of matplotlib to plot the ADJ close column. plt.figure brackets fig size equals brackets 15, 5 close brackets plt.title brackets Apple stock prices for 5 years close brackets plt.xlabel brackets year plt.ylabel brackets price plt.plot brackets df square brackets ADJ close, close all brackets. Let's run this cell. The graph shows how the stock prices of Apple increased over the last 5 years. In the previous example, we visualized the evolution of the stock price over a period of 5 years. Let's now visualize the evolution of the stock price during the year 2021. We can use the .loc method to match the year 2021 for the time series. plt.figure brackets fig size equals brackets 15, 5 close brackets plt.title brackets Apple stock prices for 5 years close brackets plt.xlabel brackets year plt.ylabel brackets price plt.plot brackets df.loc square brackets 2021 adj close all brackets. Execute this cell and we get the evolution of Apple stock price during 2021. This brings us to the end of this chapter and to the end of this course. Hope you enjoyed it. Thank you very much for your time and effort. I wish you the best of luck.